Good morning. I am Singh Ojha, Assistant Professor in Department of Electronics and Communication Engineering. Today I am going to discuss triple 5 timer IC and various applications of triple 5 timer IC. Actually, triple 5 timer IC was introduced by Signetics in 1972. It is the most popular is any 555 by STM Electronics and Fairchild Semiconductors. Actually, there are several applications of triple 5 timer IC and we will discuss these applications one by one. As you can see here that there are three 5 kilo ohm resistors. You can see here. One is this and another one is this. Due to this reason, this IC named as triple 5 timer because of three 5 kilo ohm resistors used in this IC. And then you can see here there are two comparators, one flip-flop and one transistor. So, in this way this IC will work, that we will see very soon. This is a 8-pin IC which has pins as ground, trigger, output, reset, control voltage, threshold voltage, discharge and plus VCC supply. So, we will try to discuss one by one the applications of each and every component used in the triple 5 timer IC. You can see here there are three resistors which are connected in this way. This is the supply voltage VCC. And this voltage will be equally divided across these three resistors. For example, the voltage at this point will be 1/3 of VCC and voltage at this will be 2/3 of VCC and voltage at this will be the VCC. So, whatever value of VCC will be given, it should be divided by 3 to it should be divided by 3 or it should be multiplied by 1/3 and at this point it should be multiplied by 2/3 and at this point it should be multiplied by 3/3. That means the same value as VCC. Now, there are two comparators you can see here. As you all know that comparator is a circuit which compares two inputs. So, here one terminal is already fixed and another terminal will be given as some input, and similarly at here one terminal is fixed and another can be given as some input. So, we will see its working, and then the output of this comparator to be given at the R input and S input of the RS flip flop, and depending on their inputs there will be some output, and then one output is given to the NPN transistor. Why it is so, that we will see very soon, and it is NPN transistor which is discharge transistor. When we will see the application of triple 5 timer as monostable and astable multivibrator, that time we will come to know that this transistor plays a very important role. And this is the output buffer which converts, or inverted output buffer which converts high logic into low logic, and this is the pin detail of the triple 5 timer IC. Pin 1 is the grounded pin and the ground pin connects to the triple 5 timer to ground, and pin 2 is the trigger pin. You can see here it is connected here. So, trigger pin when 1/3 VCC will be given to this and it is 1/3. So, whenever it will be more than this or lower than this, that time this output of this comparator will change. That we will see when we will see its working as a monostable multivibrator. And pin number 3 is for the output, pin number 4 is for the reset, and pin number 5 is for the control voltage. This can be used to adjust the threshold voltage which is set internally to be 2/3 VCC. Pin number 6 is the threshold pin. When 2/3 VCC, it makes the change of the output of comparator, and pin number 7 is the discharge pin, while pin number 8 is the supply pin. That means for the proper operation of 555 timer, pin number 8 should be connected to the high voltage plus VCC. This is the 555 timer block diagram. So let us discuss how does this works. See, voltage at let us consider this is the comparator 1 and this is the comparator 2. So for the comparator 2, when the input is more than I mean to say that input at trigger is more than 1/3 VCC, nothing will happen. But when it will be less than this, then what will happen? Its output will change. Its output will change. That means output of this comparator 2 will become 1, and it is going to as input. That means output of this comparator will be 1 and it should be 0. Similarly, when the applied input of this threshold is greater than 2/3 VCC, that time what will happen? Output of this comparator 1 will be 1 and it should be reset. That means that time it should be 0 and it should be 1. And how does this all will work, and what is the application of this 555 timer that we are going to discuss. So before discussing those applications, let us see various modes of operation of 555 timer. There are 3 mode of operation. One is monostable, bistable and astable or free running multi-vibrator. In case of monostable, this 555 timer will have only one stable state, while in case of bistable it will have 2 stable states, either both high and low. And in case of astable multi-vibrator, this circuit will not have any stable state and its output will keep on changing from high to low and low to high. That means it will generate a square waveform. These are the various applications of 555 timer IC, like blinking LED light, police car siren, light detector and mosquito repellent and railway lights. 555 timers generally used for these applications. However, 555 timers have several other applications too. Now, let us talk about the monostable mode and let us see how does this 555 timer can work as a monostable multi-vibrator. Actually, multi-vibrators are the circuits which have capability to provide either high or low output. So as you can see here, in case of monostable multi-vibrator, there is only one stable state. As you can see here, initially this has high stable state. After that, after application of triggering pulse, its output has been changed for some small duration. After that, again you will get the high output. Similarly, if the multi-vibrator have low output stage as a stable state, then after application of triggering pulse, its output will change for the small duration that will be decided by the externally connected resistor and capacitor. After that, again it will come back to the same stable state. In this case, that stable state is low stable state. This is the pin diagram of monostable multi-vibrator. These externally connected resistors and capacitors should be connected in this way, so that 555 timer will work as a monostable multi-vibrator. And this is the functional block diagram of monostable multi-vibrator. See, what we have done, we have connected one resistor RA, one capacitor C. So what will happen? There may be the output either 0 or 1, whatever you want, you can consider. If its output will be 1, then Q bar will be 0. If it will be 0, that means this transistor will be open circuited. Or if you will consider it as a 0, then it should be 1. If it will be 1, that means this transistor will be short circuited. So let us consider initially its output is 1, then what will happen? Let us apply some input, and that input is negative triggering pulse. So when you will apply negative triggering pulse at this terminal, then what will happen? Output of comparator 2, it is less, and it is already 1 upon 3 VCC. So what will happen? Its output will change. So its output will become 1. So when does its output will become 1? That means as input of RS flip flop is 1, that means its output will become 1. And this will be 0. If it will be 0, that means transistor will become, now it will become open circuited. Open circuited means this capacitor will start charging through resistor RA towards VCC. So let us consider that this capacitor starts charging and voltage across capacitor is increasing towards VCC. So whenever the voltage across this capacitor will be equal to 2 upon 3 VCC, and when it will be slightly more than that, then output of comparator 1 will change and its output will become 1. And when its output will become 1, that means output of this flip flop will be 0 now, and it will be 1. So when it will be 1, this transistor will become short circuited. So when it will be short circuited, this capacitor will start discharging by following this path. So when capacitor will start discharging, then voltage across capacitor will decrease, it will become 1, and again you will get the stable state. So this is how the monostable multi-vibrator will work. This is the working of multi-vibrator circuit. See, so whenever you will apply the triggering pulse, only after that output will change, and again it will come back to the original state. And whenever you will apply next triggering pulse, only then its output will change for some duration, and again it will come back to the original position. And if you will talk about the capacitor voltage, so in this duration capacitor charges, and after that it discharges, and then charging, discharging, charging, in this way. And capacitor can be charged up to the voltage 2 upon 3 VCC. So let us try to find out the time for which output will remain high. You know, this is the formula of voltage across capacitor, Vc infinite plus Vc0 minus Vc infinite into e to the power minus t upon Rc. And you know that Vc0 is equal to 0 and Vc infinite is equal to plus Vcc. So when you will put these values at t is equal to Tp, Vc is equal to 2 upon 3 Vcc. So when you will put these values here, you will get this e to the power minus Tp upon Rac is equal to 1 by 3. So if you will solve it, you will simply get Th is equal to Rac into ln3, and if you will put value of ln3, it is 0.69. So in this way, you can find out that for what duration the output of monostable multivibrator will change. Next is the astable multivibrator. In case of astable multivibrator, this is astable multivibrator. And in case of astable multivibrator, we have connected two resistors and we haven't given any input. You can check. So whatever input you want, you cannot give, because in this case there is no option for the input. And to understand its working, whatever output you want, either 0 or 1, you can consider. Let us consider its output is 0. If its output is 0, then it will be 1. If it will be 1, then capacitor will start discharging, and if it is 1, then it will be 0, and if it will be 0, that means this capacitor will start charging towards plus VCC and through resistor RA and RB, and when the voltage across this capacitor will be compared with 1 upon 3 VCC, and when it will be less than this, its output will change. For example, if it is keep on increasing, that means we can talk about this comparator. That means if it will be more than 2 upon 3 VCC, then what will happen? Its output will change. It will become 1, reset. That means it will be 0. If it will be 0, then it will be 1. If it will be 1, then this capacitor will become, this transistor will become short circuited, and when it will become short circuited, this capacitor will start discharging. That means voltage across capacitor will keep on decreasing from 2 upon 3 VCC, and when this voltage will be slightly less than 1 upon 3 VCC, then output of this comparator will change and it will become 1. This will be 1, that means this will also be 1, this will be 0, and this will become open circuited, and now in spite of discharging, it will keep on charging towards VCC. So in this way, this capacitor will keep on charging and discharging, and voltage across capacitor will be varied from 1 upon 3 VCC to 2 upon 3 VCC, and output will keep on changing from 0 to 1, 1 to 0, 0 to 1, and 1 to 0. In this way, this circuit has the capability to generate a square waveform. This is how the voltage across capacitor will change, and this is how you will get output. And one more important thing that we need to remember is this capacitor will charges through path RA and RB. That means for charging, RA and RB plays an important role, and while discharging, see, this is the path for discharging, only RB will come into the existence. So actually, we will find out T1 and T2. That means we will find out the charging and discharging time. So in case of TS, that means the time for which the output will remain high, we can put at T is equal to TH, VC is equal to 2 upon 3 VCC. So if you will put these values here, you will get TH is equal to 0.693 RA plus RB, and for the discharging capacitor, you can see it very easily that VCT is equal to VC infinite plus VC0 minus VC infinite into to the power minus T upon RC, and VC infinite is equal to 0. So if you will put these values, you will get TL is equal to 0.693 into RBC. So what will be the total time period? Total time period T will be equal to TL plus TH. So you can add TL and TH. So you will get 0.693 RA plus 2 RB into C. Now what is duty cycle? You know, duty cycle is T on upon T on plus T off. So TH we have calculated as 0.693 into RB plus RB into C upon TL plus TH. That means total time was equal to 0.693 RA plus 2 RB into C. You can put these values here. So you will get duty cycle is equal to RA plus RB upon RA plus 2 RB. And if you will multiply it by 100, you will get duty cycle into percentage. And what should be the frequency of oscillation? You have find out this T, and frequency of oscillation is nothing but 1 upon time period. So you can simply divide it by 0.693 upon into RA plus 2 RB into C. So this factor will become 1.45. So frequency of oscillation of A stable multivibrator is 1.45 upon RA plus 2 RB into C. So in this way, this circuit can be used to generate frequency, or it can be used to generate a square waveform or of any required frequency. This is how the triple fab timer works, and this is how we can use triple fab timer as a stable multivibrator and monostable multivibrator.